Dr. Danielle Rappaport is a forest ecologist who uses nature sounds to measure the health of the Amazon rainforest.
Landsat has allowed us to map those changing dynamics and get a really wonderful, objective, annual time series of how humans have been modifying the Amazon forest.
Landsat helped Danielle and her team target areas of human activity, bumping up against the Amazon forest, a region known as the frontier. From there, she used bioacoustics to assess the effects of human activity on wildlife.
Landsat was really the backbone of this study.
Danielle is one of thousands of scientists that has paired Landsat data with an entirely different data set to uncover a more nuanced understanding of the world. In many cases, one set of data can tell you what is happening, while Landsat can tell you why it's happening.
So the case that we always look at is the Middle East, where pivot irrigation has led to a depletion of groundwater.
Basically what that means is, the NASA satellite GRACE picked up some strange readings in the Middle East that indicated their groundwater had suddenly decreased by an alarming amount. Landsat later revealed the cause via images of the land surface. Over the past several decades, Saudi Arabia had begun to employ a method of irrigation that was so water-intensive, it literally changed Earth's gravitational pull in that particular region. These partnerships between satellites sound great. After all, teamwork makes the dream work. But how do you make two different data sets from two different satellites sing? Here's the secret. Different data sets are complementary and not in competition. See, Landsat data tells us about local conditions on the land surface: forests, neighborhoods, farms, deserts, farms in deserts. Meanwhile, GRACE gives a broad regional view of water levels underground. Using the two together deepens our understanding of the world, letting us see what causes led to which effects. But GRACE is not the only partner for Landsat. The European Sentinel-1 uses radar to see through the clouds that block Landsat's view, while Landsat reveals the colors and characteristics of the surface. And NASA's JEDI uses laser pulses to measure the height of trees and help map the biomass of a forest. This nicely complements Landsat's view of the canopy top, which assesses the health of the trees. Not to mention the long data record that lets us track changes over decades. Landsat is also a great complement to other similar land imagers. In fact, our friend Jeff has done a lot of work to harmonize Landsat and Sentinel-2 data. Back to you, Jeff.
Sentinel-2 is very much like Landsat. It's a Landsat-like system that the European Union has fielded since 2015. And so the real key there is putting Landsat and Sentinel together, because increasingly what people are looking for is a daily observation at that kind of resolution. You know, there's been almost an explosion in the number of Earth resources satellites, Earth observation satellites that are out there in the international community. In addition to Sentinel-2, India, Brazil, China, Thailand, they all have their own Earth observation programs. Increasingly, it's about putting all of that together and harmonizing the data, or at least using them in time series kinds of ways to really accelerate the use.
What does it mean to be worthy of a legacy? 8 generations of Landsat satellites have quietly observed a changing Earth from 438 miles above for almost 50 years. Like most things worth doing, it hasn't been easy.
I think the Landsat program today is probably healthier than it's been in a very long time. Right? We have 2 operational satellites on orbit now. Landsat 9 will join the fleet in 2021. And then in the late 2020s, we'll have the Landsat Next system coming up. We don't exactly know what that's going to look like yet, but the planning is in place, and I'm confident that it's going to be there.
Born during a time of limited technology, Landsat's founders were dreamers who laid the foundation for limitless future innovation. As we change, so do our forests, farms, cities, and suburbs. It's a mission that spans generations, and one that we can rely on to tell us what's actually going on when the surface of our planet goes through transformations. Now we're launching Landsat 9, the continuation of that dream. We've enlisted our best and brightest to work on this decades-long mission, and we will for decades to come. 50 more years of Earth data in the future.